IBC is 72 employees strong, located in 4 U.S. facilities, focused on transforming the world through innovative special alloys and the products they are made from. Well, mission is part of the foundation. So you start with the culture, the people, the mission, and the values. And from there, you build up the enablers. The enablers are the market and your roadmap for your technology and your products. After that, it's the strategy. It's the financial plan. It's the execution plan. It's your marketing plan. And then it's the risk management. And finally, execution exists at the top. And if you follow that pyramid and you build a solid foundation, you will make a great company. We are focused on being a great company that makes a difference. I start with the values because I believe that is the foundation of a great company. If you think about what you want to be 3 years from now, you can focus on the products and on the bottom line. I choose to focus first on the people, the culture, the mission, and the vision of the company. And if we get that right, and we bring that to every single person in the company, then the focus on delivering great products at reasonable prices will happen as a result of that. Again, so for us, delivery of great product to the customer, inspiring our employees, providing a safe environment, and a reasonable return for our investors. That's my focus. And that's what innovative companies do. In regards to beryllium-aluminum, you have to understand the process. There is over 600 degrees Celsius in terms of the melting temperatures of the two metals. That means that they coagulate or come together at different rates. That's a challenge for the materials companies. So typically, the material has been made in block form first and then cut to size and hogged out to make the final pieces that are used in aerospace. That's very expensive. At the Engineered Materials Division, we've developed a process that allows us to cast that material in a near net shape. That reduces substantially the amount of material used. It increases the cycle time in terms of product to the customer, as well as a significant savings to our customers. IBC has turned into the corner now because a lot of the initial investment in the casting technology is past us. We now have a fully qualified material and process to be able to do the engineered materials work with beryllium-aluminum. We will continue to innovate, and so some of the cost structure will be built around having funds to do that. But having said that, the largest expense to be able to reach market with our casting alloys is behind us now. We are currently producing for Lockheed Martin the azimuth gimbal ring that goes into the electro-optical targeting system of the F-35. The gimbal ring is where all the electronics are housed that allow it to stare through the glass that you see coming through the bottom of the airplane. That gimbal ring needs to be extremely insensitive to vibrations. The engines vibrate, the acoustic air traveling around the airplane. And so the ability to stare or see down to optical ranges is all about eliminating vibration. Think about having a pair of binoculars. It doesn't matter how powerful those binoculars are if your hands shake. So we are removing that jitter by using beryllium-aluminum in that housing. And for Lockheed Martin and for our warfighters and for our nations, 9 countries total buying this airplane, we're making it cheaper than they were able to do so being taken out of the block form and then hogged down to the individual piece. So we're very much focused on meeting the requirements for the F-35 program. But besides that, we are now in prototyping for BAE Systems for a part that I'm very excited about because it is really in the sweet spot for our casting process. It looks like there is going to be a significant number of parts in terms of demand for that. And we're now focused on 3 other aerospace companies that have the same kind of component. Sweet spot of our casting process, looking like they're going to get to rate. So for engineered materials, it is all about rate. Now, once we move past these individual divisions, the individual market sectors, I believe the next place that we're going to be looking at is going to be in the specialized sports arena. How can we move into Formula One racing or NASCAR? How can we move into high-end cycling or components where weight and strength make a difference? And so I'm very excited about it. As the price point of our products come down, you will see us move into mainstream, aerospace, automotive, and other defense sectors. And it's all about price point. Copper is still coming out of the bottom right now, but I do believe the velocity is positive. We're going to focus on execution and on what are the key components that those customers need today in terms of fulfillment and on special new alloys. Things that we can do within our capital plan to improve the quality of the products that we produce today that will meet a higher demand. I firmly believe that is coming up. If you take a look at rig counts, they are increasing right now in oil and gas. Oil and gas prices are stabilizing. Consumption is increasing. We're seeing the same thing in automotive. We're seeing the same thing in it. So I believe demand will increase. But it's not just about the copper alloys. Remember that this is a specialty metals services company. We're going to have the ability to be able to make different semi-products or finally formed products in the future. We're also going to be focused on what are those new chemistries that allow us to expand in the marketplace. Let me talk a little bit about scandium. Scandium is a special material when mixed with other alloys will increase the strength or the lightness of the material. We're looking at scandium alloys as a potential for aerospace, space, defense, and automotive. Why? Our president of EMC has 2 patents that were previously filed by both Ford Motor Company and Boeing Aerospace that use a scandium aluminum alloy. The problem for both of those companies, though, has been the availability of scandium. So we are currently in a joint venture with NioCorp, who is now in the process of producing in pilot form scandium from a mine in Nebraska. So we are in advance of the delivery of that material, looking at the markets, looking at the engineering processes, and putting all of that in place to find those early adopters of this material. Ultimately, I think it's going to make a huge difference for aerospace because of its lightness, to be able to reduce weight of aircraft, to have better fuel savings, and to reduce emissions to the environment. As well as automotive, same reason, reduction of fossil fuel requirements. I'm very excited about the potential for scandium alloys. While I was every rank from second lieutenant up to major general, I was primarily in aviation. I flew A6s initially, then I became a United States Navy test pilot, got to do some great work for 4 years, made a transition to F-18s, flew those for several years, and then got promoted into acquisition. Acquisition is about understanding how to make great products for our warfighters. I got to run several neat programs, and ultimately I became the program executive officer for the F-35 Joint Strike Fighter program, a fabulous airplane that will transform how we do warfare in the future. Yes, my son, Captain Derek Heinz, United States Marine Corps, is currently an F-18 pilot. He has finished his first tour at the F-18, done a tremendous job, including boat operations off the Eisenhower, supporting operations in Afghanistan. And he, for a very long time, questioned whether or not he wanted to be part of the F-35 program. Primarily a timing question, as well as not sure that I want to give up a great airplane for an unknown. He then got an opportunity to fight against an F-35 and then with an F-35 in formation against an adversary scenario. And he came back to me and said, "Dad, putting in my package." So he has submitted his package. The package was accepted. He's at school for a year right now. We'll go back down to start training on the F-35 next year to fly the airplane. So I get to live vicariously again through my son in terms of a military career. But it is both exciting to me and important that we get this right. Our materials, our special alloys, have an opportunity to make a difference for not only just our customers, but for the people that are the end users. Depending on the chemistry, you're looking for a specific property. That property may be lighter weight. It may also be greater stiffness or greater strength or greater conductivity. So depending on the end purpose of that, we design the specific chemistries to meet those mission critical needs. And by doing so, they allow the end users to get a product that reduces fuel consumption, that makes the product lighter and therefore reduces emissions to our environment. These are important cures for the difficult things that are still happening in this world. I would tell an investor to look closely at our company because of the great potential. We start with great people who are passionate about delivering great product to our end users. When you look at the customer base, that customer base is very much intrigued by our capabilities and very much starting to adopt and innovate around the chemistries that we make to bring new products to market that help solve the world's biggest problems.